Find the point on y equals square root of x that is closest to 3, 0. Let xy be a point on y equals square root of x. We want to minimize d, which is equal to the square root of x minus 3 squared plus y minus 0 squared. So we want to minimize the distance from the point xy to the point 3, 0. We want that distance to be as small as possible. The constraint is y equals square root of x. Now, if I minimize the square of the distance, I will have minimized the distance. And so, keeping that in mind, I'm going to let s equal d squared. So let me say that again. If I minimize the square of the distance, I will have minimized the distance. And it's easier to minimize the square of the distance because you don't have to deal with any square roots. And so if I replace y with square root of x, I get s of x is equal to x minus 3 squared plus the square root of x squared. And so s of x is x minus 3 squared plus x. The domain is the interval 0 to infinity where 0 is included. Take the derivative. So s prime of x is 2 times x minus 3 plus 1, which is equal to 2x minus 5. Set s prime of x equal to 0. So 2x minus 5 is equal to 0. Solving for x, we get x equals 5 halves. That's my critical number. Okay? Now, we set up our interval. So we have the interval from 0 to 5 halves and the interval from 5 halves to infinity. I'm going to test x equal 1 in the first interval and x equal 3 in the second interval. S prime of 1 is less than 0, I claim, and I put the derivative down here. So if you notice, if I replace x with 1, s prime of 1 is negative. So that means s is decreasing, right? Decreasing on the interval 0 to 5 halves. And then when I plugged in x equal 3 into the derivative, I got s prime of 3 is positive, which means that s is increasing, right, on the interval 5 halves to infinity. What does that mean? That means s has a minimum when x equals 5 halves. If x equals 5 halves, y equals the square root of 5 halves. So we can make this conclusion now. The point on y equals square root of x that is closest to 3, 0 is 5 halves square root of 5 halves. Okay? Now, we can come over here for a second and remember that d is the square root of x minus 3 squared plus y minus 0 squared. And I already told you that the point closest to 3, 0 is 5 halves square root of 5 halves. And so then the question becomes, how do I get that distance? And so remember, the first coordinate corresponds to x, the second coordinate corresponds to y, and then I would plug those values in. And so I get 5 halves minus 3 to the second plus square root of 5 halves to the second. Okay? And this is the square root of 5 halves minus 3 is negative a half. So you get negative a half squared plus 5 halves. Now, if I come off to the side here, if I square negative a half, I get a fourth. And then I'm going to add 5 halves. And getting that common denominator here, I'm going to multiply numerator and denominator by 2. and I get 11 over 4. So this is the square root of 11 over 4. But remember that the square root of 4 is 2. And so the smallest distance will be the square root of 11 divided by 2. That's fine. I don't mind you leaving it in exact form. Okay, that'll conclude this video. This is section 4.7, and we looked at problem number 26. All right, thank you.